Today we're going to talk about finding the area of a regular polygon. Area of a regular polygon. How do I find the area of a regular polygon? If you remember a regular polygon, all the sides are the same. All the interior angles are the same. The formula for the area of a regular polygon is equal to 0.5 times little letter a times big letter P. Little letter a represents the apothem. The apothem of a regular polygon is the distance from the center of the polygon, distance from the center to the middle of a side. Okay, the distance from the center to the middle of a side, and that's at 90 degrees. At 90 degrees. So it's a perpendicular segment. The big letter P, that's the perimeter of the shape. Perimeter of the polygon. All right, this is a multiple step process. So I'm going to try just listing out the steps. And then we're going to do a couple problems just following those steps to hopefully make it a little bit easier for you. So let's write the steps down. Step 1. We're going to draw the shape. And write the formula. We're going to draw the shape and we're going to write the area formula. Step 2. We're going to draw the apothem and the central angle. Step 3, determine the angle measure formed by the apothem and radius. You're going to determine the angle measure formed by the apothem and the radius. Step 4 is to identify the missing measurements. Step 5 is to use Sohcahtoa to find those measurements. And step 6 will be to substitute. Substitute and find the area. Now, after we do an example problem, this will all make a lot more sense. All right? Everybody caught up? All right, so what was step 1, Marcus?
Draw the shape and write the area.
All right, so let's draw a regular triangle. As close as you can. One of the sides is given. The top is 10. And the area formula is equal to 0.5 times apothem times perimeter. What was the next step? Draw the apothem. The apothem goes from the center of the polygon to the middle of a side at 90 degrees. Central angle is formed by segments connecting the vertices to the center of the polygon. In a regular polygon, those are referred to as the radius. They're congruent to each other. The blue lines form the central angle. All right? The central angle in a regular polygon, the central angle is equal to 360 divided by the number of sides. In this case, we got 3 sides. So the central angle, the angle of the two radiuses, is 120 degrees. Now, the apothem bisects that angle. So what was the next step?
Determine the angle measure formed by the apothem.
Thank you. Determine the angle measure formed by the apothem, the red line, and the radius, a blue line. All right, so if the apothem bisects the central angle, what will the measure of that angle be? 60 degrees. Very good. What kind of triangle does this form? It's a 30, 60, 90 right triangle, isn't it? Okay. Now, since it's a regular polygon, this apothem bisects one of the sides. So this measure right here is how much? That piece is 5. All right, what was the next step? Somebody please read it out, because I don't have them in front of me. It's 4 pages ago.
Identify missing measurements.
Identify the missing measurements. So we need the apothem and we need the perimeter. If one of the sides is 10, then what's the perimeter of this shape? Good, 30, because the sides are all the same. It's a regular triangle. So 10 times 3 is 30. So what are we missing now? You're missing the apothem, aren't you? Okay? You're missing the apothem right here. But the apothem is one side of a 30, 60, 90 right triangle. So you can either use the rules from special right triangles, or you can use Sohcahtoa. All right? And since you're going to have, I'm going to use Sohcahtoa since you got to use it in a bunch of the other problems today. So if you take the acronym and in this triangle you're dealing with, you got the 60-degree angle, you know the opposite side, and you're looking for the adjacent side. Opposite and adjacent deals with tangent. So tangent, tan 60 equals the opposite side, which is 5, over the adjacent side, which is the apothem you're trying to find. If you multiply both sides by a, the a's will cancel, and then you'll have to divide each side by tan 60. So 5 divided by tan 60 2.89. Now you've got your apothem. All right, so now you can substitute and find the area. So you've got 0.5 times 2.89 times 30. 43.35. It's the area of that regular polygon. Any questions on any of those steps?
Where did you get the 60 degrees in your triangle?
The 60 degrees. All right. The apothem, the red line, is from the center to the middle of a side at 90 degrees. So when I drew that in there, I was allowed to make that a 90-degree angle by rule. The angle formed by the two blue lines. The blue lines, those are radiuses, and the radiuses of a regular polygon form a central angle. All right? If you take 360 degrees and divide it by the number of sides, it'll give you this. It'll give you this entire measure. That entire measure. So that entire angle is 120 degrees. The apothem splits that angle in half. That's where you get your 60 degrees. That's the angle formed by the apothem and the radius. All right, let's try a pentagon when you're given a radius. A pentagon, and you're given a radius of 7. And your area formula is 0.5 times apothem times the perimeter. All right, you got the shape, you got the formula written. What was next?
Draw the apothem and central angle.
All right, apothem goes to the middle of from the center of the shape to the middle of a side at 90 degrees. Now, part of the central angle is already there, isn't it? So the rest of the central angle will go from the center to one more vertex. Yes?
Doesn't matter which side you draw it to, right?
Mm-mm. No, but when you're drawing it, draw the apothem and the central angle to the same sides. Because you're trying to create this right triangle that you're going to work with.
Okay.
All right, so if the radius on the left is 7, the radius on the right is 7. And next is to find the central angle.
Yeah.
All right, so in this case, now your central angle is equal to 360 divided by, there's 5 sides. 360 divided by 5 is 72. 72 is the central angle. But remember that the apothem bisects the central angle. So the angle formed by the apothem in the radius is 36 degrees. So that angle in there is 36 degrees. And now if you find the length of the red segment, the apothem, and if you find the length of this segment right here, this segment, the side opposite the 36, will be half the length of the side. If you find that length, you can double it, and it'll give you one of the sides of the pentagon. And then you multiply it by 5 to get the perimeter. So let's find the apothem first, this red segment. All right, if you use sine, cosine, tangent, you're dealing with hypotenuse and adjacent. Hypotenuse and adjacent is cosine. So cosine 36 equals adjacent over hypotenuse, which is 7. If you multiply each side by 7, 36 cosine times 7, 5.66 equals the apothem. It's one of the measurements you were missing. If you want to call this leg of this right triangle the letter X, well, now you're going to be dealing with opposite and hypotenuse. So to find this portion of this right triangle, opposite and hypotenuse is sine. So now you can do sine 36 equals opposite over hypotenuse. Same process, multiply each side by 7. These will cancel. And 36 sine times 7, 4.11 equals X. Well, if you double that, it'll give you the side of the triangle. So it's sitting in your calculator, hit times 2. You get 8.23 as a side length. Well, there's 5 of those sides, so times 5 in the calculator. So the perimeter is 4114. Now that number is still sitting in your calculator, so you can just do the area formula backwards if you want. Do perimeter times apothem times 0.5. So times 5.66 times 0.5 equals 116.44. Does anybody have any questions on any of those steps? It's all stuff that we've done this year. Just unfortunately for you, it's combined into one problem. Questions?